AS-ANASEP Septic Tank and AS-ZEON Earth Filter. Due to the ever-increasing interest of people in effluent treatment techniques and low-energy or aisle solutions for their housing facilities, the so-called extensive treatment methods are growing in their importance. Such techniques are suitable for both family houses as well as localities that are not occupied permanently. However, in some cases, energy supply will be necessary for pumping purposes, and solar power pumps can be favorably used there. These solutions are mostly considered even for recreation facilities, particularly those in high mountainous localities or protected landscape areas due to their technological advantages, typically suitable in cases of irregular recreational occupancies. As it can be seen in the performance efficiency diagrams, these solutions show more stable results. In practice, they're typically represented by mechanical pre-treatment, a septic tank, or an anaerobic treatment unit finalized with another secondary treatment stage formed by various biofilters, earth filters, root wastewater treatment zones, or biological stabilization tanks, usually designed according to discharging methods. That is, either to water streams or soak-away trenches, or to a disposal without discharging. As a single wastewater treatment step, septic tanks are not permitted. However, the efficiency and service time of downstream treatment steps, such as earth filters, will depend, to a substantial degree, on the wastewater pre-treatment level. The septic tank performance is given by the efficiency of its volume utilization. That is, by the retention time of treated wastewater in the tank, which is directly connected with a layout system preventing the occurrence of short-circuit streams. In the framework of the ANASEP project, the AS-ANASEP Septic Tank was designed by the use of mathematical modeling and consequently verified in practice. This septic tank can divide the flows in a manner that its hold-up or retention time is increased even threefold higher in a comparison with conventional three-chamber septic tanks. Naturally, this leads to an increase in efficiency, as well as in a decreased production of sludge. Consequently, the sludge production can be further reduced by the use of various biopreparations. In a like way as the septic tank, anaerobic treatment units, such as UASB reactor, can be directly used. However, in both solutions, it'll be necessary to account for the fact that due to the anaerobic processes there, the ammonia content in the effluent will rise. Therefore, biofilters or sorption units capable of intercepting ammonia are used in the next stage, where the ammonia content is removed due to the aerobic nitrification bacteria growing on the filter charge, if suitable conditions are created. Apart from the above-mentioned economically less demanding solutions, it's also possible to remove ammonia chemically, electrochemically, or using advanced oxidation processes, or AOPs. Sorption processes are mostly used, and the use of zeolites, or microporous aluminosilicate minerals, seems to be suitable especially for their capability of intercepting ammonia selectively. On the other hand, the sorption ability diminished over time mainly due to the capacity exhaustion, and therefore the sorbent is to be replaced usually once a year. On the opposite, the biofilter is running into its full capacity over time. In the framework of the ANASEP project, the proprietary and protected AS-ZEON filter, which combines the advantages of sorption in the startup phase and filtration over the service time later, has been developed. In this, it'll be necessary to respect several rules: the aerobic environment and bath-wise supply of the filter, which is provided by pulse dosing of water to the filter, for example by a shaft with an overturned trough. Austrian experience shows that the distribution piping can be situated even above ground, without a risk of freezing in the winter months. The so-called root zone treatment unit operates on the same principle as biofilters or earth filters. In its principle, the root zone treatment plant is a biofilter with vegetation on its surface. However, the influence of treatment process by the plants is minimal, where the plants perform rather an aesthetical function. Therefore, the filter structure is of the prevailing importance. Cleaned water can be subsequently either discharged into water streams, or soaked into various drain systems, or disposed in other effluentless systems. Let's have a look at discharging in terms of nutrient components represented by phosphorus and various nitrogen forms. The important parameter for discharging cleaned wastewater to water streams is the phosphorus removal level. This is achieved by adding the slag component into the filter or further independent sorption filters with suitable filter media added downstream. However, the simplest way to achieve such parameters is the use of phosphate-free detergents in washing machines and dishwashers. In case of larger treatment plants, the quantities of discharge water are taken into account. A measuring unit is usually placed at the discharge where, for instance, the Thompson's triangular spillway represents suitable equipment. In case of a smaller plant, these quantities are measured indirectly, for example, from the water consumption. In view of the environmental protection, it's not excessively important to be particular in the phosphorus removal if the cleaned effluent is discharged to underground water bodies, because phosphorus is trapped in the soil anyway. On the contrary, it's important to eliminate insoluble matters and provide for a complete removal of nitrogen in the downstream denitrification stage, for example, by a horizontal filter. The ammonia content in wastewater can also be reduced by measures taken in housing sanitary facilities, for example, by separation of urine. Another possibility of wastewater disposal is the so-called effluentless solution, such as a pond with vegetation or irrigation of cultivated plants. ASIO can offer a system suitable for wastewater irrigation purposes. However, an excess of water that cannot be used must be drained to a larger wastewater treatment plant at any rate. A possibility of sanitization of cleaned water using a UV radiation source has been studied in the ANASEP project. It's been confirmed that the sanitization is effective in such cases, for example, the removal of bacterial contamination, even up to the drinking water quality, with the quality guaranteed for water used for bathing. An independent category alone involves soak-away systems, by which the water is infiltrated to rock environments, where it consequently sweeps away subsurface to underground water layers. In some cases of confined space possibilities, the soak-away system situated under the earth or biofilter can be advantageously used. Here are some advantages. AS-ANASEP has several times higher hydraulic efficiency and retention time in a comparison with conventional septic tanks, higher efficiency in terms of removal of organic contaminants, minimization of released insoluble matters and therefore prolonged service life of downstream equipment, and longer intervals of sludge removal and therefore savings in sludge disposal costs. AS-ZEON has high purification efficiency immediately after the filter installation due to its sorption properties, long service life and high efficiency due to the growing bacterial culture, removal of ammonia even in housing facilities used irregularly, and operations with minimum power consumption, or even without it.